Okay, so this one again, we already refer back to the concept of theory of statistical testing. So we have null hypothesis and also alternative hypothesis. So we will concentrate in this chapter is on the power of function. Okay, the power of function of the test. So again, we have the element of statistical test. So you have to know what is null hypothesis, alternative, conduct the test statistic. Okay, how you want to define your critical region or find your critical region. And then we have the definition for type 1 error, type 2 error. Okay. Type 1 error, again, rejecting H0 when H0 is true. Okay, so probability is defined as alpha. So if we have type 2 error, probability of accepting H0 when H0 is false. So this one is probability of type 2, type 2 error. We call this one as beta. Okay. So we have the concept for power function of a test. So actually the power function of a test represent the ability of the decision rule to recognize correctly that H0 is false. Okay, so that's mean power function is the probability of rejecting the null hypothesis given that it is false. Okay, so again, it's defined for all distribution under consideration. So you can consider, let's say, if we have binomial, we have Poisson distribution, we have normal distribution, Bernoulli distribution, apa lagi? And then maybe some of the question relate to the ordered statistic, gamma distribution, and so on. Okay. So the next one, okay, it is a function that yields the probability of rejecting H0 under consideration. Okay. So which yields the probability that the sample point falls in the critical region C of the test. So probability of rejecting H0 under consideration. So that's mean we will consider what is your H0, the value of your true parameter. Okay, under your theta naught, let's say theta naught equals to 5, and then you want to test theta naught equals to 6. So that is the meaning of probability of rejecting H0 under consideration. Okay, so the value of the power function at a parameter point is called the power of the test at that point. Okay, again the same thing lah. Let's say mu equals to 5 or mu equals to 6. That is your power function of a test. So basic standard definition, it is a probability of rejecting the null hypothesis given it is false. Okay. So how this one relate to the alpha and beta? So again, the concept is probability rejecting H0 when H0 is false. So that's mean 1 minus probability fail to reject H0. That's mean probability accept H0. So 1 minus probability fail to reject H0 given H0 is false. So this one is 1 minus beta. So that means this is the power of the test when your H1 is true. So maksudnya if your H0 is false, your H1 is true. So you already know what is the definition for beta. Beta is probability accepting H0. Or similarly, I write fail to reject H0 given that H0 is false. So that is your beta. Okay, so the power function of a test also can be defined as probability of not making type 2 error. So why is the probability of not making type 2 error? Because we have 1 minus beta. Okay. So again, if we have alpha, alpha is your significant level, size of your critical region, the power of the test when H0 is true, because alpha is probability rejecting H0 when H0 is true. Okay, so maksud K theta tu, the power of the test is probability rejecting H0. So we have to consider either your H0 is false, that's mean 1 minus beta. If your H0 is true, that means you are computing your alpha, your significance level. So bila dia minta, let's say, compute the power function of the test. So you can consider two things. So let's say you can consider probability rejecting H0 when H0 is false, probability rejecting H0 when H0 is true. But if you already calculate, or let's say the question asks you compute the significance level alpha. So that means you already compute your alpha. So if the question asks you find the power of the test, so you just compute probability rejecting H0 when H0 is false. Okay, so clear? Okay, so the same thing, this is the relationship. Okay, the relationship between beta, alpha, and also K theta. Okay, So power of a test depend on several factors, including the choice of alpha, the sample size, your n, and the true value of the parameter. So as the sample size of the sample increase, it will increase the power of the test. Maksudnya semakin besar kita punya nilai n, the power of the test will be increasing. And also if the significant level alpha increase, the power of the test will also increase because alpha to define probability rejecting H0 when H0 is true. Okay, so alpha increase, the power of the test also will increase. So dia punya relationship macam ni So kamu ada beta, so here is your beta. Okay, so this is your alpha, this is your k theta. So beta 0 up to 1, alpha 0 up to 1. So ini k theta kamu 0 up to 1 here. Okay, so let's say dia punya curve dia punya curve, let's say and alpha is equals to 0.1, your beta is equals to 1. Okay, so but your k theta is almost 0. But when you increase your alpha 0.9, your k theta may be around 0.9 lah over here. Okay, so dia punya titik kat sini. So that is the relationship between significant level alpha and also your beta and k theta, the power of the test.